Okay, so we are starting class 10 chemistry chapter 2. Okay, so take your tuition copy, your textbook, and the tuition note. Okay, tuition note that you got while you were taking admission, right? So you take those three. You can leave aside your textbook by the side and take mainly your tuition note and tuition copy. Okay, and this is important, your tuition copy, what you're going to write there. So chapter 2. Okay, chapter 2 is you write it down: acids, bases, bases, and salts. So this chapter we are going to study three things: acids, bases, and salts. So write along with me as you do this. Okay, so we will go through the questions. This can be explained directly, so take your tuition note and follow me. So definition of acids. Okay, basic definition. Before we start, you just imagine you squeeze some lemon juice. Okay, lemon itu limbu tengah na, and then in a cup, and you test it on your tongue. Take 2-3 drops and test. What is the test? Yes, it is sour. So here sour, underline the word sour. And then you take a blue litmus paper. This you will get in the school laboratory. Okay, if you get a piece, and you put it in the lemon juice that you. So the blue litmus paper, not any ordinary paper, but it must be litmus. Okay, blue colored litmus. You dip it in the lemon juice you squeezed. It will turn red. Again, we repeat, the lemon juice is giving a sour taste, turning the blue litmus paper to red color. Okay, so those substances, that is the basic, simplest definition of acids that are sour in taste and turn blue litmus paper to red are called acids. Whereas bases, usually bitter substances are bases. Okay, so you take a base substance, squeeze its juice or something, then you test it, it will be bitter. If it is bitter, let us say, and you take this time the opposite of blue, you take red colored litmus from your school laboratory. It is easily available. Okay, so you dip it in that solution which is bitter in taste, it will surely turn blue. So those substances which have bitter taste and turn red to blue litmus are called bases. So that is the most basic definition of acids and bases. Okay, example of some common, the word common means you'll find in your very easily in your kitchen and all, that are acidic or basic. Acids, the common substances you'll find in your kitchen: lemon, vinegar, not used for cooking. Okay, vinegar is just that acetic acid dissolved in water. Tinga, you'll be tinga, so that is acid. Tamarind, imli tenga, you know na, imli tenga janena. All those substances which are tinga in taste, sour in English and Nagamese is tinga, they are the common ones you find in your kitchen also, or in the dukan. They are called acids. Okay, and then bases that you easily find are baking soda. I do cake can bake kora chulaina, only bread, baking powder. Okay, baking soda specifically, or soap. Okay, sabun. All those are common, easily available substances that are examples of bases. So you take your own note, yes, and remember the examples. Okay, now this portion that starts from question number 1 is 3A plus test. Okay, take 1, start from here, and then it'll end to question number 16 here, page 44, I think. Yeah, oh, sorry, 41, page 41 up to question 16. This, when you complete this portion, be aware you will be giving a test called 3A plus 2A. Okay, 3A plus you have already taken B. Okay, now next question: if a person is suffering from problem of acidity, means gastric because like that you tell na, due to overeating, what would you suggest as a remedy? Lemon juice or vinegar or baking soda? Now the answer is here. Okay, how is gastritis caused? Gastritis means the pain in the gastric of your stomach because of release of HCl acid. Our stomach secretes HCl. Okay, And when we overeat, sometimes the secretion increases abnormally and causes irritation and pain to your stomach, and that is called gastritis. So the pain is because of the HCl, which is acid. So in order to cure that, we need an opposite substance. Now if you take lemon, lemon is acid. You just now heard. Tinga na, tinga khan thali acid ase no. Or vinegar be acid ase. Just now see acid. So if you drink these two juice, your pain will increase because the pain is caused by acid. But if you take baking soda, which is opposite nature of acid, then the baking soda will cut the neutralize or cut the HCl, okay, and so the pain will decrease. So the answer will be the baking soda and not lemon juice and vinegar. Why they are asking that also? So here the reason is because baking soda solution is the only substance which is basic, opposite to HCl, which is causing the pain in your stomach. So that can neutralize the acid. The answer is it's opposite and can neutralize the acid because it's a base. Okay. Now, next question: what are acid-base indicators, or simply they are also called as indicators? In order to understand that, don't read the definition, just listen to what I'm going to say. Simple example, I'll take something you already know. You can underline if you want. Turmeric. Turmeric mane Nagamis Hindi de haldi ko na sabji fry kore de chole na dal khan. Suppose you are taking a sabji which is mixed with turmeric, haldi, and it's stained on your white shirt. Okay, what is the color? Do you remember? What is the color when it's stained on your shirt? Yes, you're right, it is yellow. Now you take a piece of soap, okay, soap, sabun, and then wet your shirt where it's yellow with turmeric, with soap little bit. Then suddenly it turned brown. That means the yellow turmeric turns color to brown in bases, because you know just now soap is a base. You see, example of base is a soap. So those kind of substances like haldi, turmeric, which change color in base or acid, so that we can detect the presence of an acid by the change in color. That helps substances that help us to detect acids or bases, okay, by the change in its original color, are called acid-base indicators or indicators. They help us to detect presence of acids or bases by the change in color. So did you understand? You can read them through. Pause the video, okay, and you can read them through. I'm going to continue, okay. Now, other examples, I took the most common one, turmeric. The other examples of substances that change color in acids and base are: litmus will have one color in acid and a different color in base. That's the meaning, okay. Litmus paper, litmus solution, litmus paper. Methyl orange is another substance solution. Phenolphthalein solution. Turmeric we've done. Cabbage, that kobe leaves also change color. They show different colors in acid, which is different from its color in base. So they can help you detect. Colored petals means phul laga kyo petals kan na of flowers, like some flowers like hydrangea, okay, petunia. Your mother will know this also, she may be having at home. Geranium. All these petals of these flowers also help us to indicate acids and bases by the change in color, okay. You can pause the video and read them once. When you're done, you continue the video. We'll go to question number 4, okay. Now question number 4, here we see here here acids turn remember this, okay. Acids will turn blue litmus to red color. When you take blue litmus paper or solution and put it on an acid, the acid will turn the blue to red. Will not change the color of red litmus. But if you put red litmus into acid, the color will remain red itself, because it's turning blue to red now. So litmus is red in acids, but when you put blue litmus to acids, it will turn red, okay. And it will turn phenolphthalein solution from phenolphthalein original color is pink, okay. When you put acid, okay, phenolphthalein into acids, the phenolphthalein color pink will disappear to colorless, and so you know that's an acid, and will turn methyl orange. Acids will turn the methyl orange color to red. So you tick the yes. So this is a matter of just memorizing and remembering color changes. Okay, and then next here, bases. Bases will turn opposite to this. Acids turn blue to red. So you can just remember. Do not need to memorize. So bases will do opposite, red to blue. Acids do not change color of red, so base will not change the color of blue. Okay, does not change the color of pink phenolphthalein. Acids turn pink phenolphthalein to colorless, but the pink color of phenolphthalein will remain pink in base. Okay, and acids turn methyl orange to red, but bases will turn methyl orange to yellow. So compare with acids, it becomes easier to memorize this for bases. We take their yes. Okay, these are important. Next, why do the yellow stain in turmeric from curry stained on a white cloth, I told you just now, on a white shirt, turn reddish brown when soap is scrubbed on it? We have already done, so I'll just read through it. Why does it turn back yellow? Again, this we can explain. When washed with water, again, clean water. Yellow color of the turmeric turns reddish brown in bases like soaps. When you put soap is a base. So the yellow stain from curry turns reddish brown in bases. So the yellow color stain from curry here turns reddish brown when soap is scrubbed or applied on the cloth, because soap is basic, no? And bases always turn yellow turmeric to brown, reddish brown. Just now we learned. That's the reason. Now, when we wash with plenty of water again, it turns back to its original color yellow. Why? Because water has neutral pH. That means it is neither having acidic nature or basic nature. That's why it restores back the color to the original color yellow, because water it's not acidic, it's not basic also, and turmeric yellow is neutral solution. So, and turmeric is yellow, always a neutral solution like water is not acidic also, basic also. Okay, now what is a litmus solution? These are just definitions we have to go through. A solution of purple dye. Okay, purple dye means color. A purple color, in simple words, extracted means taken out from a plant called lichen. This plant belongs to division Thallophyta. So you just need to remember those things. The dye purple color taken out from this plant, which is used for acid-base indicator. Means they show different colors in acid as depth compared to bases. So when you put them in base, it show one color. When you put this purple dye in acid, it will show a different color, and so it will help us to know whether that solution that we're testing is acid or base. So they're called indicators. It's called litmus solution. So it's an indicator solution. Now litmus solution is purple when it is neither acidic nor basic. So when you dissolve this litmus, this one here, purple dye, in distilled water which is neutral, not acid also, base also, then its color will be purple, original color will be there. But when you dissolve in acid solution, it will be red. When it is in blue solution, it is in basic solution or medium, it will be blue in color. Remember that. So original color of purple litmus solution is purple in neutral solution, but red in acid and blue color in base. Okay, so you can tick there yes. So next, question number 9. The color of red litmus paper remains red and blue paper remains blue when dipped in distilled water, which is neutral. In other words, distilled water or neutral solutions do not change the color of blue or red litmus. That's correct. When you dip blue or red litmus paper into blue or red, whatever color, into a solution, and there is no change in color in both color, blue or red litmus, you can be sure that that's neutral, means it is not acid also, it's not basic also. Example is distilled water, pure water does not change the color of litmus paper because it is neutral. Only acids can change. No? Acids can change from blue to red and bases red to blue. Just now in question number 4 we did. Right, so here, number 10. This is important. You have been provided with, this is question number 1 on your textbook, page 19, okay? You have been provided with 3 test tubes, okay? One of them contains distilled water, but we don't know which one is distilled, which one is the other ones. And the other 2 contains acidic solution and basic solution respectively. But the problem is we don't know which is which. They did not label it. They did not write on the test tube. So if you're given only red litmus paper, now red will turn blue in the basic one, but it will remain red. But how will we test the neutral? So problem is there, because you are given only one type of paper, red litmus. How will you identify, means how will you tell which one is acid, which one is base, which one is neutral? Very simple. You can write this one down on your notebook. Okay, question number 10, write down. This is the first question you're writing on your tuition copy. So take the three solutions A. These are the three solutions. Let's write roughly. So one is neutral, one is acid, one is base. But we don't know now. So what you do is that take a few drops here, and then take three separate okay, a few drops. So cut the red litmus paper. This is a red litmus paper. So cut here, cut here. So we have three pieces, 1, 2, and 3. Red litmus. Red litmus only is given to us paper. So what you do, cut it with scissor into 3 parts, red color. Now take 2-3 drops of this and put it here, let us say. Then take 2-3 drops of this and put it here. Take 2-3 drops of this and put it here. Now surely we know one of them is acid, base, and neutral, but we don't know. Problem is which one is which, we don't know. So suppose A is turning this blue, red color paper to blue. It turned blue. Let us say it turned blue. It turned blue, right down. Then what must be A? Just now we read that. Question number 4, go back. See here. Acids turn blue to red, but bases turn red to blue. Now this is the only solution turning the red litmus paper to blue. So we can now know this solution is base. We now know. So we can separate this test tube. No need to deal with it anymore. But here we did not see no change in color. No change in color for both this. Here also no change. Here also no change. So one is neutral now, one is acid, because base is already sorted. Now how do we do it? Now we know that acids will turn blue to red. So this paper, which is now wet blue paper, you cut into 2 again, small pieces. So this is what? Wet litmus, wet blue, which was originally red, turned to blue because of the liquid base. Blue litmus, wet litmus paper, wet. Now put few drops of B here to one of them, and few drops of C to here. Now let us say C is turning this wet blue color to red, but there is no change in color in the B. So what will change red, wet blue to red litmus? Blue to red. See here, blue to red is acids can only do the blue to red. So this one, which the solution C, which is turning the wet blue to red, is surely now acid. And there is no change in color, means we know neutral solutions do not change color of blue or red also. So this is neutral. I hope you got it right. Now you pause the video yourself and go and read question number 10 and answer also. Okay, and replay the video if you are not getting it. Otherwise, you play the video again and go to question number 11. Okay. So here question number 11 is saying we'll just use this. Okay. With an activity, means like experiment sort of thing. Explain how acids and bases are identified in the laboratory. A laboratory is a place in the school where you do experiments. So by activity means experimental method. The common substances in laboratory, how can you identify which are acids, bases? Like hydrochloric acid, sulfuric acid, nitric acid, H3, acetic acid, sodium hydroxide, calcium hydroxide, potassium hydroxide, magnesium hydroxide, ammonium hydroxide. All these are very easily available and common in the school laboratory, and we frequently use them for experiments. We want to know which are acids and bases. In order to do that, remember these 4 and 5, okay? Acids turn blue to red, does not change the color of red litmus, turns phenolphthalein from pink to colorless, and methyl orange to red. You get this one very thoroughly. Then bases turn red opposite to blue, does not change the color of blue litmus, does not change the color of pink phenolphthalein, and turns methyl orange to yellow. Okay, you get that thoroughly. Thoroughly means without doubt. Okay, without doubt you get it. Now once you get this, question number 4 and 5, and we do this experiment, okay, step 1, you collect all these substances. Then step 2, you put a drop. Each of the above solutions were put on watch glass, means flat kind of bati kind of small glass. Okay, there 2-3 drops one by one, and of these substances HCl, all these 2-3 drops, few drops, okay, one by one, and test with a take 1 drop each of the indicators shown in table below that I'm going to show. The color change observed with red litmus, these are the indicators, blue litmus, phenolphthalein, methyl orange were found like this. So since this year, as you do this experiment, okay, as you do this experiment, see here, we found out that this, all of this, hydrochloric acid, sulfuric acid, nitric acid, acetic acid, up to here 4, when you put 1 or 2 drops in them of red litmus, red, there is no change, and only acid can do that, right? Then blue, there is turned to red litmus solution. Phenolphthalein, pink color changes to colorless. Methyl orange changes to red. We know now from question 4-5 that only an acid can do that. So HCl is an acid. So also sulfuric acid, nitric acid, acetic acid behave the same way. So 1, 2, 3, 4. These common laboratory substances are known to be acids by test in the laboratory like this. Now when you did with sodium hydroxide, potassium hydroxide, magnesium hydroxide, ammonium hydroxide, all of them turn the red color to blue. Only base can do that. Blue to in the blue solution, blue litmus, there was no change in color. Only base can do that. We know that from question number 4 and 5. And the phenolphthalein pink color remained pink, no change. That's only base can do that. And then methyl orange turned yellow. In always, it is always yellow in base, not methyl orange. It's always red in acid. So all these are now known to be bases. So we can identify bases and acids among the common laboratory substances by this experiment. Okay. Now, so this is how we do it. You can just read through them yourself, pause if you want, or go to the next question. Okay. The next question is here, question number 12. We'll do directly here. It's quite easy. Okay. So here, question number 12. Here, question number 12 is, with an activity, explain how onions, so we're going to use common ones, piyaz, vanilla, clove oil, can be used as acid-base indicators. Can we use them from the characteristic smell? Now, most of the indicators are change in color. So far we've discussed, right? But there is not the only type of indicator acid-base. We can, some substance also show change in smell, not color. They can also be used to detect acids and bases. Okay, so here step 1, some finely chopped onions. So you cut the onions in small pieces like you do, along with some strips of clean cloth like cotton cloth, cut with scissor, small pieces like this size, 2 finger size or 1 finger size, 9-10 of them, and mix it with the chopped onion, and then keep it in your fridge overnight like that, in a bag, okay, in a cotton bag or something. And after overnight means after 7-8 hours, 12 hours, 2 of these cloth strips in the we put in the onion, you take it out, then add few drops of dilute HCl, which is a acid we already know, on each cloth, okay, and 2 drops each of sodium hydroxide were put on the other. So on one cloth you put 2 drops of HCl, and on the other piece of cloth 2 pieces enough. The cloth dipped in onion, you put the base sodium hydroxide. What do you observe? Both the cloth strips were rinsed. Then after that you wash with water and check the smell. Okay, when you smell, the one in which the cloth in which you put the HCl, the acid, the smell of onion was still there, but in the one where you put NaOH, the smell of onion disappeared. So we know now when a base is put in onion, the smell will disappear, vanish. When you put a seed into onion, the smell will remain. So through smell also, like that we can know. Vanilla, same thing, some diluted HCl solution and diluted NaOH solution. Dilute means diluted in water, not strong base. Therefore, we're taking in two separate test tubes. Okay, then few drops of vanilla. After taking two test tubes like this, you put 5 ml of HCl dilute and NaOH. Then 2-3 drops of vanilla. Vanilla means vanilla is an essence, it's a smell. Okay, used for smell in food and all. So you put 2-3 drops of vanilla, you'll find out that in the acid, the smell of vanilla was still there, the original smell was there. But in the base, the smell disappeared. Clove also same. You take 2 test tube, 2 clove oil, put 2-3 drops of acid in there, clove oil, and 2-3 drops of base. This in the acid, the original clove oil smell is still there. The base disappeared. So this type of substances which change their smell in base by vanishing or staying are called olfactory indicators because they help us to know by smell. The word olfactory simply means something to do with smell with your nose. Okay, so what are olfactory indicators? So you read them yourself. Substances like this, just now clove oil, vanilla, whose odor means smell, changes in acidic or basic media, and therefore used as acid-base indicators on the basis of smell, not change in color, are called olfactory indicators. Example, just now we took onion, vanilla, essence. Essence means smell, and clove oil. Vanilla essence and clove oil. Okay. Now we go to the next question. That is your question 14. Okay, 14 is, we will do this one here. Briefly explain how acids and bases react with metals. So reaction of acids and bases with metals is what we're going to discuss. Okay, with a neat diagram and activity. Write the required balanced chemical equation. We'll do that later on. Okay, so here you arrange your test tube like this. Then before you put this cork, the covering that muk bone cork was na, do not like it. You put the metal. Zinc is a very good metal for reaction, so zinc metals. There is nothing here now. Okay, only zinc metal solid, because if you close the mouth, the zinc can be put. After that only you put this dhakna, which is having 2 holes. The dhakna has got 2 holes. Cork means dhakna, rubber dhakna. Through one hole you put thistle funnel. Thistle funnel means a glass through which you can pour liquid through the structure, so it will not spill. See, funnel, kerosene, petrol type, but it's glass transparent. We can see inside like that. It must be. Then in the other hole you put a delivery tube. Delivery tube means a glass test tube that will lead to another place. Okay, so that is the one. After that, you slowly pour dilute in this thistle funnel. You pour any acid. Okay, you can try with sulfuric acid. Dilute sulfuric acid, H2SO4. Slowly dilute, not concentrated. Pour it till this one here. The thistle funnel la niche dekhi to tip to na. Itu acid la niche de deep hobi means half pour na it a gap na thakibi. Kyona whatever gas comes out will go out through the thistle funnel if you do that. So let the tip, downward tip of the thistle funnel immerse in the dilute H2SO4 liquid. Then when you do that, immediately you see some gas bubbles. You will see. Okay, you do this experiment. Add H2SO4 acid or any acid to zinc metal, some gas bubbles will come out, colorless, and it cannot go through this because liquid is, the tip is deep, so it will not escape. It will go through this delivery tube, colorless, and come out here. Now this bath here, you put sabun na surf olop milagena rakhibi. So sabun laga solution, soap solution. So when this gas that was produced here comes, it begins to produce soap bubbles because of the gas that is formed inside. Now bring a candle near this one of these gas bubbles and burn it. This gas that was produced here will burn with a blue color. Remember blue, and a violent popping sound like popcorn, pop, like that it will burn. The only gas that burns with blue color and popping sound like that is hydrogen. So we know now, whenever metals react with acids, we always get hydrogen gas. That's what we're trying to get. So let us write the equations. Okay, so take your notebook. Write question number 14. Okay, next question number 14. So today we'll learn okay, any metal you take. So just take here, keep some gap here. Okay, now you're going to learn to write formula. Keep some gap here and write here. Write here zinc. Then write a symbol for zinc. We know as starter worksheet. Zinc ion is, don't write now, okay, Zn 2 plus. When we say zinc ion, we'll write this. But when we say zinc, it's not the ion, it's the atom. So always write like this. Similarly, calcium ion, Ca2 plus. Calcium means Ca. Everything will go like that, okay? Okay, now put a plus sign here in the symbol. We have to write the chemical equation now. Now zinc is reacting with sulfuric acid in the experiment we did just now. So right here, dilute. Right below this, okay, sulfuric, because you need space this side for the chemical equation. Dilute sulfuric acid. Now write the formula above this one. Worksheet 1 double plus. Now you did sulfuric acid. Yes, you're right. So H2SO4. Then what happens is this. I'll go to page 47 of your textbook. Go now, and on page 47 of your textbook, there is a table. There you see, all of you, take your own textbook and see. Zinc, the metal you're taking here, is above or below hydrogen. Find out. Hydrogen is here, now see? So definitely above hydrogen, meaning zinc is more reactive than hydrogen. So this reaction will take place. What we mean by that is, there, see, we have to displace this hydrogen. So you don't need to do this in exam, okay? But in practice copy you do. Definitely zinc can push this hydrogen out, coming out. So write hydrogen. You know the formula of hydrogen now in worksheet 1 double plus. So right there. So only metal that is above hydrogen can do, like zinc is above. It'll come out and then it'll take this place. So what will be if zinc come and combine with sulfate radical? What is the formula? Yes, that's right. The only thing you'll get is just below the plus, you write zinc sulfate. So write the formula by remembering the starter. Zn2 plus, then sulfate ion, SO4 2 minus, so 2 cancel, so ZnSO4. So you get this. Now this will be called a salt, okay? And then this is the hydrogen gas. Now you can try with more if you want. Take the same metal zinc, okay, Zn, write it below this. Try with dilute hydrochloric acid instead of sulfuric acid. Is the result the same with other acids? That's what we're trying to do. So